For each of these rational functions, we need to find the domain, holes on the graph, and intercepts of the rational function. I mean, these are rational functions. Okay, for the first part A, to find the domain is real numbers, all real numbers except those x values that make the bottom 0. So we got x plus 8 on the bottom, so x plus 8 is 0. Subtract 8 from both sides when x is negative 8, and we got x minus 1 becomes 0 when x is 1. So domain is all reals except negative 8 and 1. Okay, that's the domain. In this question, in part B, we need to factor, then we can see what x values make the bottom 0. And the same way, let's factor the top. 81 is 9 squared, so x is squared minus 9 is squared. That's the difference of two squares. So that's x plus 9, x minus 9. We can factor in this way over the bottom is a trinomial, quadratic trinomial, so if it factors, it will be a product of two binomials. So x is squared, that's the x times x. Now 18, we need to find two factors whose sum is 11, all positive, so it's going to be all plus. So 18, 2 times 9, 18, 2 plus 9 is 11, so 2 and 9. So for this question, the domain is all real numbers except those x values that make the bottom 0. So x plus 2 is 0 when x is negative 2. X plus 9 is 0 when subtract 9 from both sides, x is negative 9. So the domain is, domain is all real numbers except these two, negative 2 and negative 9. Okay, and when it's factored, we can see that let's come back to the first part. There is no cancellation from top and bottom because x plus 8 is a block, x minus 1 is a block. So there are no cancellations, means none of these two bad points, kind of, for domain, these are bad points. None of these are holes on the graph. That means the function, this rational function, has vertical asymptotes at x equals negative 8 and x equals 1. So there are two vertical asymptotes, by the way. But in this question, we can see x plus 9 cancels. That means at x equals negative 9, we have a hole in the graph. Okay, so hole at x equals negative 9, because these two factors cancel. But here, no hole on the graph. And they have not asked, but when we have these two exclusions from the domain and they are not holes, that means they are vertical asymptotes. So VA, vertical asymptotes, x equals negative 8 and x equals 1. So in this case, vertical asymptote at x equals negative 2, because this did not cancel, so negative 2. Okay, that was not asked, but I'm just giving you this extra information about vertical asymptotes. No holes on the graph. In third part, we were asked to find the intercepts. Intercepts means, if hole does not exist, say no. So no hole, that is holes, none. Okay. Intercepts means x intercepts and y intercepts. Okay, y intercepts are easy. Y intercept, there will be only one, in fact, and and same as x-intercept, there can be more than one. Okay, my bad. Y-intercept, there will be always only one for a function. So all we have to do is plug in x0. Go back and plug in x0. So when we plug in 0, 4 times 0 times, it's 0 on the top anyway. On the bottom, 0 plus 8, 8, minus 1, negative 8. So 0 over whatever number is 0. So y-intercept is y equals 0. For x-intercept, we have to set the function function equals 0 and solve for x. So there are no cancellations, so we need to simplify. There are no cancellations, and 0 equals this fraction. So 0 equals this fraction. 0 is same as 0 over 1. Now cross multiply. Then the bottom times 0 is 0, so top times 1 is just top, equals 0. What happens is, after we simplify to find the x-intercepts, we just set the top equals 0. Bottom has no contribution. Okay, or you can do a little bit of work. So x-intercept 4x, x minus 3, 0. 4x, x minus 3, 0. Okay, so either 4x 0 or x minus 3, 0. We are solving for x. Divide by 4. So add 3. So there are 2 x-intercepts. So x equals 3 and x equals 0. Okay. For this rational function, after we simplify, we can work on simplified function for intercepts. H is x minus 9 over x plus 2. Let's find y-intercept. So y-intercept, we just set x0. So y equals, set x0, 0 minus 9, negative 9 over 0 plus 2, 2. So negative 9 halves. That's y-intercept. And for x-intercept, after we simplify this fraction, set the top equals 0, because this y is 0 and 0 is 0 over 1. When we cross multiply, bottom will be just 0. So bottom has no contributions. For x-intercept, we just set the top 0. 9, x minus 9, 0. Add 9, so x equals 9. So we got one x-intercept. I mean, there is always only one y-intercept. Here y-intercept 0, and there are 2 x-intercepts.